Hi, we're speaking to Dr. Meyer, who is an ecologist, who's going to give us a roundup of her work in ecology. Hi, Dr. Meyer, thank you for joining us.
Hi, thank you for having me.
And so what first got you interested in ecology?
Well, when I was young, I just loved the outdoors and wanted to work outdoors. So I wanted to become an ecologist, and I cared a lot about wildlife. So that started me out. And then I got a job with the Park Service, the Fish and Wildlife Service, then the University of Wyoming, and now I'm an environmental consultant.
And so what does that work entail, being an environmental consultant?
Well, I help a lot of my clients clean up contaminated sites. So I evaluate the impact on the wildlife and the fish and figure out what areas we need to clean up and where we have issues.
So it's quite a lot of conservation work and protection work.
Yes.
And your recent paper, that's on European raptors and the effect of lead ingestion and other poisons. Could you give us a quick summary of that paper, please?
Sure. As the title of my paper says, we address the question, can ingestion of lead shot and poisons at the current levels seen in Europe change the trend in population sizes through time for species that are susceptible to those poisons? And the three species we looked at are shown here, and they're the common buzzard, the red kite, and the gray partridge. Now these two species are raptors, and raptors feed on prey, and the prey can be hunted and get lead shot them, they cripple, they die, and then these raptors will start feeding on them until they get exposed to the lead shot. They also can be exposed to bait poisons. So folks will lace bait with poisons in order to target predators, or also rodents, mice and rats. And then if these predators start feeding on the bait and get into that poison, then they become exposed to those bait poisons. And we also looked at the gray partridges. They're generally out in agricultural fields, and so they're picking up the lead shot from the ground, and they mistake it for grit and ingest it. And they also can ingest granules of pesticides and seeds that are coated in pesticides. So we're really looking at categories of those types of poisons and lead shot and how it affects the population trends out in the field. And we looked at population models as our tool for assessing the trends. And we went out to certain study areas and then modeled the population trend for that study area, and then superimpose on that the effect of the lead shot and the poisons to see how it changed. So the answer to the question is yes, there was an effect on the trends from these poisons and lead shot, but it was an effect on the magnitude, not the direction of the trends. So for example, with the gray partridge, we looked at a study area in continental Europe where the population is declining over time. And when we removed lead shot, it increased the number of animals by 10%. When we removed also the poisons, that increased another 8%. So you have 18% difference, but it was still declining over time. And then when we looked at the common buzzard, we looked at a stable population in Germany and found that the lead shot and poison really didn't affect it very much. It's like less than 1% change in the population size, and it was still stable. But then when we looked at the red kite, we looked at a location in Wales where the population had been decimated to very low levels in the mid-1900s. And so it's been slowly recovering over time, and it's an increasing population. But when you add lead shot, it didn't change the direction and make it start to be stable or decreasing. It was still increasing, but the magnitude changed. And you can see that with this graphic here that shows the red kite population size on the vertical axis and the year across here. And if you look at the lowest two lines, dashed lines here, they represent scenarios with lead shot and poison, and the growth rate's very low, just a few percent. But then if you remove the lead shot, that more solid line shows the effect where now you get 6% growth per year when you take out lead shot. And then when you remove the bait poisons, boom, it really increases all the way up, almost to carrying capacity with that dashed line. And you're increasing from 200 pairs here to, could have up to 2,000 pairs if you didn't have those bait poisons. So clearly the bait poisons are strongly driving the trends for the red kite. And this is very useful, using these population tools, because they help us determine these trends and figure out, among all the variability out there, what's affecting the variability, which stressors are main drivers and which are not. So that's what we hope, is people will start using population models more often to evaluate and rank stressors and their importance in the environment.
So what this work has sort of shown is that one of the biggest things that is limiting red kite breeding pairs is the poisons.
Yes.
And shots.
And many, much of that is illegal poisoning too. Some people are deliberately targeting those hawks, unfortunately, because they don't want them. They think they're going to take their lambs or, chickens or game birds. And some of it's just from secondary poisoning. Inadvertently or targeting something else, and then the birds got into it. But the red kite feeds on a lot of carrion, and it's very similar to a vulture. So it's highly susceptible to it, more so than the buzzard, which feeds a lot more on live prey and not as much in carrion, which is probably why we didn't see as much effect for the buzzard.
Do you think this is a similar effect that will be happening on hen harriers, for example?
Well, I think the hen harriers might be more similar to the buzzard if they're feeding a lot on live prey. So it kind of depends how much of their diet is carrion. The higher the percentage is carrion, the more likely they're going to be like a red kite. The lower, the more likely they'll be like a buzzard. And
other mammals, for example, like foxes or badgers that might be eating carrion, do you think they're also going to have a similar effect as being shown in the birds? Yeah, if they are feeding on carrion, like foxes a lot of times will feed on dead carcasses, they can pick up the lead too and also have impacts. And we didn't actually study those species, so I can't tell you the magnitude of the effect. And what I was citing there, like 10% for lead shot effects, is a worst case scenario. A lot of times we went to areas where you had the highest lead shot ingestion or poison ingestion, look at the worst case, and it might be lower in other areas in Europe. And then you'd have to look at each species to see how much it would be. But yes, they certainly would be affected, but we haven't evaluated how much. That was going to be my next question. What's next for this research?
Well, I think I've been contacted by other researchers in France who say they have huge data sets for other vultures that are really of concern, and they'd like me to start modeling those vultures to evaluate what the impacts are of these various poisons. So that's what we're hoping, is we can now use this model for other species in Europe to help managers and policymakers have more information.
Yeah, I was going to ask about the policymakers. So do you think this will help sort of, with this information, we can limit the poisons that are legal and also use it more for stopping the illegal poisons?
Yes, I think it can be helpful for showing how important the poisons are. And it can also be helpful with just understanding the magnitude of lead shot. I wanted to show you something I thought was pretty interesting that we have in our paper that you can see with this graphic. And that is that we actually had some periods where they banned lead shot, and we wanted to see the effect. And you can't always see it when you're looking at trends through time of the data that's out there, but you can pick it up with population models. So this just shows the index to the partridge population over time. And the dark line is for Denmark, and you see the population really decreased in the 1970s, and then it's been fluctuating. And yet, see that arrow is in 1996 is where they institute a ban on lead shot, but you don't really see an improvement. And then you see over here, there's another arrow for the Netherlands. They institute the lead shot ban in 1993, but again, no real improvement. And then we do include the United Kingdom as the really light line that also shows a drop and fluctuations. And so what this shows, with the high variability often you see in populations, you can't always pick out the effect of things that are smaller stressors, like the lead shot that I said was 10% or less. But the models help you see that, yeah, there would be an effect and how much it is. And so I think it's really helpful for managers and policymakers that we then rank stressors you know, by doing these models and saying, okay, here's what's important. And yeah, you can't always pick it out looking at a trend, but our models will help tease that apart and give you that information so you can say, maybe we really need to focus on bait poison. That's number one. It's the huge problem for the red kite. And then look at the next stressor on down and focus in priority according to their ranking with the modeling results.
Oh, thank you very much for joining us. This has been really interesting. We'll put a link to the paper below this video. Thank you again for joining us, Carolyn.
Okay, thank you, Eleanor.
Thank you.
Bye-bye.